Hello everyone, this is Ms. Ortega and today we're going to be learning two things, units and unit conversions. Now a unit is the standard amount used to measure something. In science, units are super important. When scientists publish their data has to be published with units. Now units is nothing new. You've been learning about units a long time ago, maybe even before you went to school. For example, when you bake a cake and the recipe states 3 cups of flour, cups are the units. In this video, we're going to go over 3 things. We're first going to learn the common base units, then we're going to move on to prefixes, and then some practice problems. And this is where we're going to tackle our 2 big concepts of the day, which are units and unit conversions. So let's get started. The common base units that we see in chemistry for the quantity of distance or length is our units are going to be meters, and our unit symbol is going to be lowercase m. For mass, our units are going to be grams, and our unit symbol is G. For volume, our units are liters, and the unit symbol is capital L. For temperature, degrees Celsius are the units, and the unit symbol is degree with the capital C. For time, our units are seconds, and our unit symbol is going to be S. The unit symbols are to abbreviate the units. Now, are these the only units for all these quantities? No. For example, for distance or length, the units meter are not the only units. We can also do kilometers, miles, yard, feet, inches, depending on what we're measuring. Now, let's move on to the prefixes. Prefixes are important because they're the conversion factors. A conversion factor is a ratio which represents a relationship between 2 units. Kilo, hecto, deca, base unit, deci, centi, milli. Kilo, hecto, deca are much bigger than the base unit. Deci, centi, milli are much smaller than the base unit. The multiplying factors of kilo, hecto, and deca are 10 to the third, 10 to the second, and 10 to the 1. 10 to the third, if you multiply 10 times 10 times 10, so 10 3 times, you get 1,000. A kilo is 1,000 times bigger than the base unit. Hecto, 10 to the 2, 10 times 10 is 100. A hecto is 100 times bigger than the base unit. Deca, 10 to the 1 is 10, so it's 10 times bigger than the base unit. The base unit is 10 to the 0 because 10 to the 0 is just 1. Deci, centi, and milli have negative 1s, negative 2, negative 3. And this is because they're smaller than the base unit. So 10 to the negative 1 is 0.1. A deci is 0.1 of a base unit. Centi, 10 to the negative 2 is 0.01. So a centi is 0.01 of a base unit. Milli is 10 to the negative 3, and that's 0.001. And a milli is 0.001 of a base unit. Now, let's say you forget. Well, don't worry. There's a mnemonic for these common prefixes. King Henry died by drinking chocolate milk. Again, King Henry died by drinking chocolate milk. If you ever forget, just remember this mnemonic. Now, King is for kilo, Henry is for hecto, die is for deca, by is for the base unit, drinking is for deci, chocolate is for centi, milk is for the milli. Now let's take a look on these prefixes and the ratios a bit more closer. I want you to have a better understanding of the ratios of the base units. 1 kilo is 1,000 times more than the base unit. So you need 1,000 base units to make 1 kilo. 1 hecto is 100 base units. So if you want to have 1 hecto of something, you need 100 of those base units. And for 1 deca, you need 10 of those base units. The base unit is the root word. So a meter, a gram, a liter. 10 decis make up 1 base unit. Why? Because it's much smaller than a base unit. You need 100 centi to make 1 base unit. And you need 1,000 milli to make 1 base unit. So all of these are smaller than the base unit, and these are bigger than the base unit. Okay? Let's work on some practice problems. How many meters are in 895 millimeters? The first thing you have to do is ask yourself, what am I starting with and what am I going to finish with? So we're starting with 895 millimeters. That's the question. And we have to finish with meters because the question is saying how many meters. Now, we're going to do a setup. The setup for these problems are going to be what I call the picket fence or train track method. The picket fence or train track method is when you set up a table like this, a line from left to right and another line in the middle from top to bottom. Now, you're first going to write your given units, and then you're going to bring your given units down to the bottom right. And the reason we do this is so later we can cancel those units. And at the top of the given units, we're going to write our wanted units. So let's work a problem out. 895 millimeters is what we have. And based on our table, we know that for every 1,000 millimeters, we're going to have 1 meter. Then we do our math. We're going to multiply these two and then divide by 1,000. And our final answer is going to be 0.895 meters. Let's do another one. Convert 74.25 decigrams to kilograms. We're going to start with 74.25 decigrams. Now, some students might get confused, but anytime you see lowercase dg is for deci. And every time you see lowercase dag, or capital D with a G, that is deca. So since we have a lowercase d and g, it has to be deci. Don't get confused with those two. We know we have to finish with kilograms because that's what the problem is asking us to do. Our plan is a bit different than the other one. We first have to go from decigrams to grams to kilograms. The reason is because all of these ratios are based on the base unit. We cannot go directly from deci to kilograms. We first have to go to the base unit, which is grams, and then to our kilograms. So we're going to use our ratio sheet here. And our setup is a bit different. We're going to first do our picket fence. It's still picket fence. It looks a bit different, but it's still picket fence. We're going to write our given units. We're going to bring our given units down. We're going to bring our intermediate units, which in this case is G, and bring our intermediate units down. So then eventually they're going to cancel. And we're going to finally have our wanted units, which is kg, kilograms. So let's do it. 74.25 decigrams. Well, we know that for every 10 decigrams, we're going to have 1 gram. And we know that for every 1,000 grams, we're going to have 1 kilogram. And we're canceling our grams and our decigrams, and we're left over with our kilograms, which is what we want. And our final answer is going to be 0.007425 kilograms, or 7.425 times 10 to the negative 3 kilograms if you want it in scientific notation. And that is pretty much it. That's all you do. Now it's your turn to do 2 practice problems. Feel free to pause the video to go back to the previous practice problems. Anything you need to do to get the answer. Hopefully you got the 2 practice problems correct. Please subscribe to Ms. Ortega's YouTube channel for more upcoming chemistry videos. Thank you for watching. I am here to support you. I am here because I want you to be successful and have a stress-less academic year, and I hope you end up loving chemistry as much as I do.